guys,
sir.
we can focus now today on VPN concept. It means chapter number 12 and 13. So into this VPN section, first we can focus on what is VPN technology, why we are using VPN technology concept, what is the benefit to use, and if you talk about implementation, so in VPN we can discuss two type of implementation. Is called IPsec VPN and second is called SSL VPN concept. IPsec we are using for site to site VPN connectivity. It means if we have multiple branch offices, if these branch offices we are connecting over this public network, this cloud is what? This cloud is acting as a public network. If you guys are connecting these multiple branch offices over this public network, if you want to connect in a secure manner, so yes, you need to establish site-to-site VPN connectivity. It's called site-to-site. So for site-to-site configuration, we can go with the IPsec. It means to configure site-to-site VPN, we can always use IPsec option. So what is IPsec protocol? What is phase 1, phase 2 concept? We will discuss, okay? And we can do a lab. We can do a lab on site-to-site VPN connectivity on PALO ALTO. Okay, now after that, we can go on to the next concept. Is called remote access VPN. So the first one is called site-to-site VPN. And next, we can focus on remote access VPN concept. What is remote access VPN? Any idea? Jagdish, Ganu, Rohan, Yavar? What is remote access VPN? Any example? Can anyone help me?
Just like a work from home, that's the remote access. That means
Okay.
बेसिकली आप कहीं से भी उसको उसको एक्सेस कर सकते हो सिक्योरली.
Okay, securely. Okay. And if you talk about remote access VPN, so to configure remote access VPN, we have two options. Either you can configure with the IPsec or you can configure through SSL VPN concept. So, guys, to configure a remote access VPN, we have two concepts: IPsec, remote access VPN, and remote access for SSL. SSL for remote access. So now see, what is remote access VPN? In remote access VPN, see, this is the home user, you can say, or a remote user, you can say. He has simple Wi-Fi modem at his home, or you can say he has a connectivity with his laptop. This is modem, okay, Wi-Fi modem. So he has a connectivity with public network. Now over this public network, this home user or this remote user, he is trying to access company private resources. For example, this is your branch office, and in your branch office you have multiple servers. For example, this is your web server, this is your DNS server, FTP, SMTP server. So these are what? These are the servers, you can see. So this outside PC, this outside machine, is trying to access company private resources over this public network. So what he need to do? He need to establish a remote access VPN connection first with his mobile phone or laptop or desktop. You need to establish a remote access VPN connection first. Once this connection will establish, then yes, he is allowed to access. Now he can access company private resources over this secure VPN connection, and the complete traffic in between his laptop and this gateway device is fully secure, fully encrypted, you can say. This type of connection is called a remote access VPN connection. And to configure remote access VPN, you can go with the IPsec or you can go with the SSL VPN. So today we can focus on first, what is VPN? What is VPN concept? After that, we can focus on IPsec discussion. IPsec, what is IPsec technology? What is IPsec concept? And then we can go on to the lab, site-to-site VPN. Site-to-site VPN on Palo Alto Firewall box. So this is our task. This is our task right now today. So let's talk about first, what is VPN? What is VPN? So VPN is called virtual private network. It's a virtual, okay? So it's a virtual private network. For example, you have two branch office A and branch office B. If you want to connect these two branch offices, then what you can do? You need ISP connection, right? You can connect these branch offices through this ISP connection. ISP connection, you can say public network, you can say, or untrusted network, you can say. So this is your public network. Public network. So to connect these two branch offices, we can use public network. So yes, we can connect like this. And let's take example, we don't know anything about VPN, for example. We don't know anything. And if we are connecting these two branch offices over this public network, over this untrusted network, so now, what is the issue? What is the problem we can face? So in case, see, so the scenario is what if traffic is traveling, for example, if traffic is traveling through this untrusted network, So you can see, guys, this site A is on public network, this site B is on public network, and attacker, you can say, or hacker, you can say, he's also on public network. He's also on untrusted network, on internet. So in case if traffic is traveling through this untrusted network, so it may be possible, this attacker can capture this traffic, in between site A and site B, and can verify what's going on or what type of traffic is traveling in between site A and site B. Attacker can verify, can capture the traffic information because it's a publicly available. Traffic is what? Traffic is traveling through the public network, untrusted network. That is the issue. Okay, traffic is traveling through the untrusted network. That's why in this case, in this scenario, what we can do, we can establish a secure connection in between branch offices. What we can do, we can establish a connection, you can say secure connection. This connection is called VPN connection. This connection is called what? VPN. So you can establish a connection here like this, a connection in between site A and site B over this public network. This connection is called virtual private network, and this connection is fully secured. Okay, and now this time if you are sending your traffic, through this VPN, IPsec VPN tunnel or through this connection, so your traffic is fully secured, fully encrypted. In case if attacker is trying to capture this traffic information, he's getting encrypted data. Or you can say he's getting garbage, you can say. He don't know anything about the data. He is trying to decrypt it, but he cannot. So that is the use of, VPN, or you can say that is the benefit of VPN. We can secure our data over public network, but we need to establish a VPN connection. So if you have VPN connection in between site A and site B, so we have multiple features. VPN can provide you multiple features. The first feature VPN can provide you is called what? Encryption. The first feature VPN can provide you is called encryption. It means if traffic is traveling now through this VPN tunnel, is fully encrypted. This traffic is now fully encrypted. In case if attacker is trying to capture, he's getting encrypted data and he cannot decrypt it. For encryption, we are using method, everyone. Rohan, Genu, Jagdish, Yavar.
Sir.
Yes, sir.
Okay, so for encryption, we are using method. We are using method. It's called, you can say we are using parameter. For example, DES. DES is called Digital Encryption Standard. What is DES story? This is not our topic, okay? What is DES? This is not a cyber security class. This is not ethical hacking class. Okay, what I'm telling you, there is a DES concept. That's it. If you want to in deep, so yes, you can go with the cyber security or ethical hacking class. But right now, I'm telling you what, we have a parameter. DES. DES is what? Digital Encryption Standard. And DES will provide you 56-bit of encryption. If you are using DES parameter, then if you want to go for the higher bit encryption, so yes, you can go with the triple DES. Triple DES is called same digital encryption standard, but it's a triple DES. It means if you can multiply 3 times, so 168-bit. Triple DES can provide you higher bit. If you want to go for the latest option like AES, now for encryption, everyone is using AES, Advanced Encryption Standard. Why? Because in AES we have variation. I'm talking about bit size. Okay, we have variation. Like with AES, we have 128-bit, 192, 256. So we have variation. We have a big bit size, you can say. So the first feature VPN can provide you is called encryption. Clear now my point, Jagdish, Yavar, Rohan, Genu?
Yes, sir.
Yes, sir.
Okay, now, so as now encryption is there, so attacker cannot decrypt it. If attacker is trying to capture the traffic information, he is getting encrypted data. Now, that is good, okay, that is good. That we have a good feature. But again, we can face a problem. See, traffic is encrypted, no problem. Traffic is encrypted. In between side A and side B, traffic is encrypted. But again, we have a problem. Problem is what? Wait. So traffic is encrypted. Now traffic is traveling. Sorry. Traffic is traveling and attacker is trying to capture the traffic information. He is getting encrypted data. He cannot decrypt, but he can change something. He cannot decrypt it, but he can change. He can add some malicious information, some instruction into the traffic and then send it to the other branch office. It means he cannot decrypt it, but he can tamper your information. He can tamper your information. He can change something. That is the issue. That is the problem. That's why VPN will provide you. The next feature is called hashing. Hashing. What is hashing? Hashing will provide you data integrity. Data integrity. No one can tamper your data. No one can change anything in VPN connection. That is the feature. That is the VPN feature. With hashing method, no one can decrypt no one can change anything in your data. For hashing, yes, we are using parameters. Either you can go with the MD5, is called message digest, or you can go with the SHA. SHA is called secure hashing algorithm. SHA is popular. Why? Because in SHA, yes, same. We have variation. Maybe we have variation. I'm talking about bit size, like SHA-1, SHA-256, SHA-384, SHA-512. SHA is called what? Secure hashing algorithm. MD5 is called what? Message digest. You cannot say which option is good, okay? It's depend upon your scenario, depend upon your organization requirement, okay? You can decide MD5 or SHA. But these are what? These are the hashing method. So if I'm using hashing, for example, if I'm using here a key is called CCIE. Behalf of CCIE, it will generate a hash value. And now with your traffic, hash value is traveling. Now in case if attacker is trying to capture this traffic information, he can capture, let's say example, he can capture, okay, now he's trying to decrypt, he cannot decrypt, but he's trying to change something. So once he changes something in traffic, then the hash value will change. If attacker will change anything data, so then the hash value will change. And you can see on both branch office, I'm using same hashing value. I have a same key, CCIE. Same key. It means I have same hash value on both branch office. If attacker will change anything, then hash value will change. And now this time, if attacker is trying to send this traffic information on other branch office, site B will not accept the data because the hash value will change. Clear my point? Ganu, Rohan, Yavar, Jagdish.
Yes.
So the first feature is called encryption. No one can decrypt your traffic in VPN tunnel, in VPN connection. No one can change anything in VPN. That is the feature of VPN. Okay, what is the next feature? Next feature is called authentication. Authentication. What is authentication? See, now we have encryption, hashing, so no one can decrypt traffic, no one can change anything. Perfect. Now site A is trying to send the traffic. Site A is trying to share the traffic information with site B. Okay, the traffic is encrypted and hashing is working. So now he's trying to send the traffic information to site B. So how site A will verify or identify site B is a valid site? How site A can identify or verify site B is a valid site? It's actual site. How? That is the issue. That's why we have a feature is called authentication. Here we are using a method is called authentication. Actually, we have two type of authentication. The first one is called pre-shared key method. The first method is called what? Pre-shared key. Method is called what? Wait. Pre-shared key. Pre-shared, it means same key we are using, same authentication key we are using on both branch office. That is called pre-shared. It's a method. You can go with the other option. We have another option. It's called RSA. We have public to private combination option, certificate server. So we are not talking about this. Okay. Our focus is on pre-shared. It means I will create same authentication key on both branch office. So for example, here we have an authentication key is called CCNP. Same authentication key we are using on site B. So if site A is trying to establish a VPN connection or trying to exchange a traffic information with site B, they will match with the authentication key. If site B has the same authentication key, yes, they can establish connection. So what we have a feature. We have encryption, hashing, and authentication. Clear my point? We have three features. Can you, Rohan, Jagdish, Yavar?
Yes.
Sir.
Okay. Now our focus is on what? Our focus is on layer 3 VPN implementation. This is our topic, layer 3 VPN. But yes, we have layer 2 VPN also. Layer 2 VPN is what? It's like, if you guys are remember ATM technology or MPLS technology, ATM, MPLS, frame relay. These are what? These are and layer 2 VPN technology. Our focus is on layer 3. So in layer 3, what you can do, you can focus on GRE, MGRE, DM VPN, and IPsec. So this is our topic. IPsec is our topic. GRE, MGRE, DM VPN. You can learn in routing and switching concept. If you go with the CCNP routing and switching, you can discuss GRE, MGRE, and DM VPN. In security, yes, our focus is on IPsec VPN. It's a layer 3 VPN implementation. This is our topic, IPsec. So now, what is IPsec exactly? What is IPsec technology? So IPsec, what do you think, guys? What is IPsec? IPsec is a protocol. Everyone, what is IPsec?
सर प्रोटोकॉल सूट है इसमें मल्टीपल प्रोटोकॉल्स इन्वॉल्व रहेंगे.
Okay, we have a product. It's a protocol suite, right? Like TCP/IP protocol suite, right?
No, sir. This is not a protocol suite. It's a framework.
It's a framework. You can say it's a framework. Same TCP/IP. It's also called framework.
But
It
only the
it means we have multiple protocols here. Okay, IPsec framework or protocol suite is the same. Yeah, okay, don't confuse. It means
Sorry, sir. Sorry, sir. Say again.
framework and protocol suite. It's the same kind of word. Okay. So,
Okay.
See, in IPsec, like in TCP/IP, if you remember in CCNA class, in we have a TCP/IP protocol suite. What is TCP/IP protocol suite? In TCP/IP, we have multiple protocols. They can work together to provide you communication. Same, IPsec is not a protocol. It's not a protocol. It's a combination of protocol, you can say, or you can say in IPsec, we have multiple protocols. They can work together to provide you secure VPN connection. Now, wait. So let's talk about some theoretical option. Okay, wait, theoretical concept. Our focus is on IPsec. So IPsec is a suite of protocol that it means we have multiple protocols in IPsec. They can work together to provide a secure VPN connection. And IPsec setup, you can say, or IPsec complete configuration is divided into two phases. It's called IPsec phase 1. It's divided into two phases called IPsec phase 1 configuration, IPsec phase 2. So your complete configuration, complete setup, you can say, IPsec setup or IPsec configuration is divided into two phases called phase 1 and phase 2. Now let's talk about what we can do in phase 1. What is the configuration option? What we can do in phase 1 and what is the configuration option in phase 2. Wait. So we can discuss some theoretical concept. Wait. Right now, I'm telling you the theoretical option, but yes, this is not a story. Okay, this is not just a story. I can show you in practical. Okay, this is not just story. So we have two branch offices called branch office A, branch office A, branch office B. This is ISP. So now, wait. Okay, so I told you guys complete IPsec configuration is divided into two phases. It's called IPsec phase 1 and phase 2. So let's discuss what we can do in phase 1. In phase 1 configuration. See, here we have two branch offices called branch office A and branch office B. We have two branch office. So in this phase, in phase 1, in this phase, what you can do, you will generate a key. In phase 1, you will generate a key that will be used later on to encrypt your data. What we can do, we can generate a key that will be used later on to encrypt your data. We can generate a key here, and this to generate this key, we are using a mechanism, you can say, in background is called Diffie-Hellman mechanism. So to generate this key, we are using a mechanism here is called Diffie-Hellman, and this key is known as session key. So what we are doing in phase 1, we are trying to generate our session key. For example, here we have a session key is called CCNA. Same session key I'm configuring here, CCNA. So this CCNA is what? It's a session key. So we need to create session key on both branch office. And to generate this session key, we are using a mechanism in background is called Diffie-Hellman mechanism. And why we are generating this key? What is the use of this key? We can encrypt our data traffic later on. Clear this line? Can you, Jagdish, Rohan, Yavar?
Yes, sir.
Sir.
Clear? So what is the next step? Now we have a session key. Now we have a session key on both branch office. So what is the next step? The next step is to exchange the session key. Okay, so what is the next step? To exchange the session key. Now we need to exchange the session key between both branch office. We have a session key, CCNA on site A, CCNA on site B. Now we need to exchange these session key in between these branch offices. So to exchange the session key, you need to set up a secure tunnel. You need to set up a secure tunnel. So now we are trying to create our first tunnel. This is called IPsec phase 1 tunnel. So you need to create your phase 1 tunnel. Why we are creating this tunnel? Why we are creating the secure tunnel? To exchange our session key. And to create this tunnel, what we required? This is done by specifying key, encryption, and hash. So to create this tunnel, we are using these parameters: key, encryption, and hash. So remember our discussion for encryption. For encryption, we have DES, triple dash, and AES. Right? So let's say example for encryption, I'm using AES, or let's say example I'm using for encryption, I'm using triple dash. Okay, remember hashing? Hashing. So for hashing, we have two methods. First one is called MD5 and second is called SHA. So let's take example, I'm using MD5 for hashing. Next is what? Authentication. Authentication, and for authentication, we have a method is called PSK, pre-shared key. In short, you can say PSK. PSK. So what I'm using for encryption, see. Okay, so to create this tunnel, this secure tunnel, we require these parameters: encryption, see, key, encryption, and hash. So for key, pre-shared key, hashing MD5, encryption, for encryption, triple S. So in case if you are using this parameter on site A branch office, so you need to use same parameter. You need to configure same parameter on your second branch office. Same parameter. Otherwise, you cannot establish this phase one tunnel. So what we have? We required key, encryption, and hash mechanism to create this first tunnel. And this first tunnel is created by using a protocol in background. Protocol is called ISA-KMP. This first tunnel is created by using a protocol is called ISA-KMP. ISA-KMP works with UDP port number 500. So why we are creating this tunnel? Ganu, Hridesh, Yavar, Rohan. Why we are creating our phase one tunnel? The purpose of this tunnel is to securely exchange the session key. Clear now? This is not just a story, okay? I can show you in lab, practically. I hope it's clear for everyone.
It is clear for me.
Okay. Now, so remember our session key. To generate our session key, we are using a mechanism is called Diffie-Hellman. So the good thing with the session key is what? We can define the size of the session key. We can also define the size of the session key. And to generate the session key, we are using a mechanism in background is called Diffie-Hellman. So in Diffie-Hellman, we have group. In Diffie-Hellman, we have group is called Diffie-Hellman group 1, Diffie-Hellman group 2, Diffie-Hellman group 5. Actually, we have multiple Diffie-Hellman groups. This is what? This is for, I'm talking about bit side again. Okay. So in case if you are using Diffie-Hellman group 1 to method, group size, okay. So to generate your session key, so DH1 will give you the 768 bit size for session key. If you want to go for the higher bit for your session key, so Diffie-Hellman group 2, 1024, Diffie-Hellman group 5, 1536. 1536. So this is your phase one, guys. What we are doing, see, remember always, in phase one, we are not exchanging our data traffic. Clear my point? We are not exchanging any data. In phase one, we are trying to exchange our session key. Why? Because we need to establish a bridge, you can say. We are trying to establish a bridge in between site A and site B. Once this bridge will establish, then yes, I can send my data traffic, no problem. So this is your phase one. Once this phase one tunnel will establish, then what you can do next? Then you can go for the phase two. You can go for the phase two. Phase two. So now we can send our data in phase two. In phase one, we are not exchanging any data. In phase one, we are trying to establish a bridge in between site A and site B. So let's talk about phase two. Phase two. So now that we have a dynamically created session key, which will expire in 1 hour by default. So the good thing with the session key is what? The good thing with the session key is what? See, behalf of this CCNA, it will generate a session key, and with your traffic, session key is traveling. And in case if attacker is trying to capture, in case attacker is trying to capture and he got the session key, it's not possible, but let's take example. He got the session key. And now with this session key, he is trying to establish a VPN connection. He cannot, because this session key will expire in 1 hour by default. By default, after 1 hour, your router, your device will generate a new session key automatically. This is the default timer. If you want to change, you can change, no problem. But this is the default timer, okay? It will generate a new session key after 1 hour. So the good thing is what? It's a dynamically created session key, which will expire in 1 hour by default. So remember our phase one tunnel, everyone, phase one tunnel. Through phase one tunnel, we can exchange our session key in phase one. But now I'm talking about phase two. In phase two, now what we can do? Now in phase two, we can create our second tunnel. We can create our second tunnel. Through the second tunnel, we can send our data traffic. Remember, always phase two tunnel is totally depend on phase one. If there is any issue in phase one, you cannot establish phase two tunnel. If phase one tunnel is okay, then yes, your device will establish phase two. And you can send your data traffic through phase two tunnel. So to create this phase two tunnel, we required only two things: encryption and hash. Only we require two things: encryption and hash in phase two tunnel. Okay, phase one tunnel protocol is called IPsec. Phase one protocol is called IPsec, but phase two is called ESP. Phase two tunnel protocol is called ESP, encapsulating security payload. Clear this theoretical concept? We can do a basic lab on Cisco device first, okay? I'm not going on PALO ALTO firewall box directly, okay? What you can do, guys, we can do a basic lab on Cisco device where I can capture the packet. I can show you some information. After that, we can go on to the PALO ALTO, no problem. Okay, our Rohan, Jagdish, Ganu.
Sir.
Do a basic lab on Cisco device first, okay? On Cisco router. Jagdish, Ganu. Clear now my point? Everyone?
Sir.
Okay, now, so please wait 5 minutes. I'm trying to create a lab setup for site-to-site VPN implementation on Cisco router. Wait, give me 5 minutes. Okay, everyone, let's take a break for 10 minutes. Genu, Jagdish, Rohan, Yavar. 10 minutes break.
Sure.
You can start
Sure.
again.
Okay.
Okay, sir.
Please, yes, please turn off your mic. Okay, everyone, can you hear me? Can you Jagdish, Rohan, Yavar?
Yes. Yes, sir.
Okay, so let's start our lab. So we are trying to configure site-to-site VPN onto these routers. Let me explain the topology first. So R1 and R3, these are the branch offices. Okay, R1 is a site A, R3 is a site B, and this R2 router is acting as a ISP router. So I will do the basic configuration, just like a real scenario. I'm doing the basic configuration. I have one branch office. This is public facing network, public facing interface, you can say. Other branch office, public facing interface. So I will configure IP address here and I will do default routing towards ISP. Okay, default routing from R3 towards ISP. Default routing. Why? Because I need to establish a connectivity from this public IP address to other branch office public IP. Because to establish VPN connection, you required source public IP and destination public IP. Reachability though. So here we have what this is what site A branch office public facing interface, site B public facing interface. So let's configure basic stuff. Basic configuration now. Let's start with the R1 first. Ten dot 1.12.1. You can see the topology. No shutdown. Loopback we can create. Show IP interface brief. Host name is site A. I'm configuring default routing towards ISP, so any network, any mask, 10.1.12.2. R2 router is acting as ISP, so host name is ISP. Let's configure 0/0 and 0/1 interface. 10.1.12.2. Done. Let's go on to the R3. R3 is a site B router, so host name is site B. 0/1 interface is a public facing interface. 23.2 I'm using. No shutdown. Let's create a loopback. Loopback is what? It's a LAN traffic. Loopback I'm using here as a LAN traffic. Clear my point? Yavar, Rohan, Jagdish. Everyone. On R1 and on R3, I have two routers. I have two loopback. Okay? On R1, I have 1.1.1 and on R3, 3.3.3. These loopbacks I'm using as a LAN traffic, LAN network. So let's configure default routing towards ISPs from R3. Done. Any problem in basic configuration, everyone? Any problem in basic configuration?
No, sir.
Okay. So now guys, you guys can verify your routing table information. So yes, we have a default route towards ISP. If you verify on R3, default route towards ISP. So what I can do, see from site A, I can only ping other branch office public facing interface right now. See, from R1, I'm trying to ping this other branch office public facing interface. Here I'm using 10.1.23.2. So from R1, I'm trying to ping 23 dot. Let's verify our connectivity. So yes, we have a reachability. It means you can say public to public IP connectivity is there. But in case if you verify your LAN to LAN connectivity, like for example, I'm trying to ping 3.3.3 with source 1.1.1. So I'm trying to ping R1 loopback to R3 loopback 1.1.1 to 3.3.3.3, and I'm not getting reply. See why? Because right now, as per real scenario, I have a 2-branch office with public to public IP connectivity. That's it. Behalf of this public source IP and destination of public IP, we can establish now our VPN connection, VPN tunnel, and then we can decide, okay, through our VPN tunnel, what traffic we want to allow. We can decide. Let's configure our IPsec VPN. So remember phase 1, phase 2 discussion, phase 1, phase 2. So this is not just a story, okay? You can configure on device. This is the configuration step, phase 1 and phase 2. So let's go on to the R1. I'm trying to configure phase 1. So in phase 1, remember, we can generate our session key. So what is the command on Cisco router? Crypto ISA KMP key on Cisco router. Rohan, any problem? Rohan, Yavar, Jagdish, Genu?
No, sir.
So crypto ISA KMP key, and now I can define my session key CCIE123. And this session key I want to exchange with 10.1.23. So what is the command syntax? Crypto ISA KMP key. This is your session key, and this session key I want to exchange with other branch office public facing interface IP. Other branch office IP, you can say. Press enter. So we have a session key on site A. Now we need to exchange our session key. So to exchange our session key, we can create our phase 1 tunnel, our first tunnel. So command syntax is called what? Crypto ISA KMP policy. And Cisco router, crypto ISA KMP policy, and you can see you have a big number. You can create approx 1 to 10,000 tunnel, phase 1 tunnel on Cisco router. So I'm creating my first one. Into this tunnel, I can define my parameters. So for encryption, you can see guys, we have 3 options: DES, triple DES, and AES. So for encryption, I'm using DES. Same parameter I will configure, I will use on other branch office, no problem. So for encryption DES, for hashing MD5, for
सर
Diffie-Hellman.
वो पार्टिसिपेंट वाला विंडो बंद कर दीजिए.
यस रोहन, क्या कह रहे हो?
हाँ सर, वो विंडो बंद कर दीजिए उस तरफ. हाँ
यस, कोई क्वेश्चन है
में.
आपका रोहन?
नहीं सर, वो एक्चुअली बस पार्टिसिपेंट वाला विंडो मेरे को बंद कर, मतलब देखना था वो तरफ कौन सा आईपी कॉन्फ़िगर्ड है.
पार्टिसिपेंट मैं समझा नहीं, फिर से पूछेंगे आप?
तो नहीं सर, एक्चुअली वो पार्टिसिपेंट वाला जो विंडो आ रहा है ना बीच में, उसकी वजह से मुझे राउटर के उस तरफ कौन सा आईपी कॉन्फ़िगर्ड है वो
अच्छा
मुझे
अच्छा
दिखाई
अच्छा,
नहीं दे
अभी
रहा.
दिख रहा है आपको?
वो एक्चुअली वहां पे कुछ ब्लैंक
हाँ, वो
डॉट जैसे
चैट
दिख
विंडो
रहा
है
है.
वो
ओके
है।
ओके ओके.
कोई बात नहीं, मैं छोटा कर देता हूँ उसको।
हाँ सर ठीक है, अभी दिख रहा है.
अब दिख रहा होगा। Now, so if you type question mark here, so group, so we have Diffie-Hellman group 1, group 2, and group 5. So I'm using Diffie-Hellman group 2. Okay, authentication. So yes, I'm using pre-shared key method. Pre-shared Yavar is a method, okay? It means same key I'm using on both branch office. Okay, so now you can press enter, done. Our phase 1 show run. Now you guys can verify our phase 1 configuration. This is our phase 1 configuration, crypto ISA KMP, see session key, and phase 1 tunnel configuration. Phase 1 tunnel configuration. Now let's configure our phase 2 tunnel. So for phase 2, command is what? On Cisco router, crypto IPsec transform set. Transform set. What does set means? It means set means what? It's a combination. It's a combination. So let's give a name for this combination first. For example, TS I'm using. This combination name, transform set name, I'm using TS. Now question mark. So for phase 2, remember we have a protocol. We have a protocol is called ESP. But you can see guys, we have one more option. It's called AH, authentication header. AH is called authentication header. We are not using a AH option. Why? Because you can see AH will only provide you hashing. See, with AH option, what we have MD5 and SHA. But if you talk about ESP protocol, so with ESP, see, it will provide you encryption and hashing also. That's why for phase 2, we are using ESP protocol. So ESP triple dash for encryption and ESP MD5 for hashing. Done. Exit. Now we can define our interesting traffic. Which traffic you want to allow through your VPN tunnel. So by interesting traffic is what? 1.1.1. If 1.1.1 is trying to communicate with 3.3.3, then yes, this traffic can travel through VPN tunnel. So on Cisco router, if you want to match your traffic, so yes, you need to configure access list. Access list 100. Why 100? If you guys remember CCNP classes, so 100 we are using to configure extended access list, right? 100 number we are using to configure extended access list. And in extended access list, we can define our source IP and destination IP. So access list 100 I'm using, permit IP, it means any protocol. Source is host is one. If host is 1.1.1 is trying to communicate 3.3.3. Done.
सर एक छोटा सा क्वेरी था। यहाँ
yes.
पे हम लोग 1.1.1.1 एक सिंगल आईपी ले रहे हैं, अगर नेटवर्क रहेगा तो कैसे रहेगा?
वाइल्ड कार्ड मास्क लेते हैं ना, अगर एसी कॉन्फ़िगरेशन आपको पता होगा तो। फॉर एग्जांपल 1.1.1, सो वाइल्ड कार्ड क्या होगा?
ओके
दैट टाइप लेनी तो
फाइन
फॉर एग्जांपल अगर 192 है 168.10.0 इस नेटवर्क को मैच करना है /24 वैल्यू है, इसका वाइल्ड कार्ड क्या होगा?
.0.0.255। अच्छा सॉरी 0। हाँ
वाइल्ड कार्ड ये होगा यहाँ पर।
नहीं सर, सी के लिए 0.0.0.255 होगा ना?
यहाँ पे होगा 0.0.0.25। क्लियर होगा ना?
ओके सर, क्लियर है।
So this is our ACL rule. This is what our ACL rule. So now what we have our phase 1 configuration, phase 2 configuration, interesting traffic. So let's map all the configuration with each other. I'm trying to map all the configuration. So for mapping, we have a command in Cisco router is called crypto map. Crypto map. Let's give a name for this crypto map. It's called CMap. Just a name. See, you can give any name here. Your name, my name, no problem. I'm using CMap. If you have question mark, you can see you can create 1,265,535 crypto maps. So I'm creating my first one. And this crypto map is what? It's IPsec ISA-KMP. This crypto map is a combination of IPsec ISA-KMP. So this is the command to create a crypto map. Why we are creating crypto map? To map all the configuration with each other. We are creating crypto map. You can press enter. If you press enter, so you are getting a notification message. See, this new crypto map will remain disabled until a peer and a valid access list have been configured. So here I'm trying to configure access list first. So please match address. Command is what? Match address, and I'm trying to match 100 number, because in 100 what we have 1.1.1 and destination is 3.3.3. So please match 100. If 100 match, then set peer address is 10.1.23.2 and set transform set is called TS. Remember our transform set name is called TS. Now this crypto map now you can apply on public facing interface. So interface fast Ethernet 0/0. Command is what? Crypto map, and crypto map name is what? CMAP. Done. Our configuration on router. See, we are getting a message IPsec is on. IPsec is on. Now let's verify our configuration again on router. Phase 1, phase 2, interesting traffic.
सर डिबग से देख सकते हैं क्या डिबग कौन फेज 1 फेज 2 फेज 3
मैं पूरा आपको दिखा रहा हूँ, शो कर रहा हूँ, बस थोड़ा टाइम। Now show run. Okay, so this is the command syntax on R. This configuration I'm trying to paste on R3. So phase 1 parameter, yes, we need to use same parameter on other branch office on R3. So for encryption, for hashing, for Diffie-Hellman, I'm using same parameter. Session key, yes, I'm using same session key, but now for R3, remote address is what? Remote address is 10.1.12.1. So let's change here. 12.1. Interesting traffic, we need to change our interesting traffic because on R3, source is 3.3.3 and destination is 1.1.1. Transform set parameter is same. Peer address, yes, I need to change my peer address 12.1. Now here we have a 0/1. Public facing interface is 0/1. Let's copy this configuration and I'm trying to paste it on R3. Done. See, we are getting a message IPsec is on. Now if you go on R1 and verify your phase 1 tunnel. So on Cisco router, we have a command to verify our phase 1 and phase 2 tunnel. Command is what? Show crypto IPsec SHA. This command you can use to verify your phase 1 tunnel. SHA is called security association. Now you can press enter. So see, we don't have any tunnel right now. Now you can also use a command show crypto IPsec SHA. Show crypto IPsec SHA command you can use to verify your phase 2 tunnel. So right now, no traffic is encrypted, nothing is decrypted. So let's initiate our traffic. But before initiating our traffic, let's try to capture. For example, I am a hacker. I can capture the packet in between site A and site B. Let's take an example. So let's verify what I'm getting. Let's verify. So I'm trying to generate my packet. So ping. Again, I'm trying to ping 3.3.3 with source 1.1.1. See? And this time I'm getting reply. See? Before VPN configuration, if you remember, success rate was 0%. Let me show you. Now, this time success rate is 100%. See, we are getting reply. You can verify your phase 1 tunnel, show crypto IPsec MP SHA. Yes, we have a tunnel in between this source public IP and this destination public IP. QM is called quick mode. QM is called quick mode. And idle state, this tunnel is what is, it is an idle state. It means it's working fine. The status of this tunnel is active. If you verify your phase 2 tunnel, show crypto IPsec SHA. So 14 packets are encrypted and 14 packets are decrypted. Let's initiate our traffic again. Ping 3.3.3 again, 5 more packet. So 14 and 5 is 19. So let's verify our phase 2. Show crypto IPsec SHA. So 14 and 5, 19. So yes, we have 19 packets. This is our VPN configuration. Now let's go on to the Wireshark. So I'm an attacker, I'm a hacker, for example, I can capture the traffic in between site A and site B. So let's verify what we are getting, okay? Let's verify. So this is our phase 1, everyone. See, protocol, IPsec MP. So these are what? This is phase 1 configuration. This is called, you can say, phase 1. Phase 1. Remember always, in phase 1, the routers or site will exchange 9 packets. Branch officer, they will exchange 9 packets in phase 1 configuration. See, first 6 packet is called main mode and last 3 packets is called quick mode. Last 3 packet is called quick mode. If you open this packet, because you are an attacker, you are a hacker, so you have a packet right now. So let's open this packet, for example, first packet. So attacker can verify. Okay, so this tunnel in between the source public IP and this destination public IP. So attacker can verify source public IP and destination public IP. And also can verify protocol. See, phase 1 protocol, IPsec MP, Internet Security Association, and key management protocol. It's called IPsec MP. UDP port number 500. So source port number is 500, destination port number is 500. So there are some informations you can see. Now if you go with the flag option, so you can see the first packet is not encrypted. Remember always, first packet is not encrypted. First, see, you can say first 4 packets. These 4 packets are not encrypted. But no problem, they are not exchanging any parameter. No, they are not exchanging any parameter. If you go and open your 4th packet, for example, so 4th packet again, see, 4th packet is not encrypted. So no problem. In what we have, see, in between branch office A and branch office B, site A is sending a blank packet to site B to verify site B is available or not, or ready or not. So site B will give a reply packet. Same, site B will send a blank packet to verify site B is ready or not, available or not. Is getting a reply packet. So this is called 1, 2, 3, and 4. So first 4 packets not encrypted, they are not exchanging any parameter. But now, if you go with the 5th packet, so yes, 5th packet is encrypted. You can verify 5th packet is encrypted. This is your phase 1. Now, if you go with the phase 2, see ESP protocol. ESP is what? Phase 2. Our phase 2 tunnel protocol is ESP. So if you verify ESP, let's generate a new packet, for example. I'm trying to ping again. I'm trying to ping 3.3.3. Ping 3.3.3 with source 1.1.1. And see, I'm getting reply, but see, this on Wireshark, we are getting this packet information. Let's open any packet. Let's open any packet. So what attacker can get? Attacker can get source public IP, destination public IP, and ESP protocol. That's it. You can see, guys, there is no any option available Okay, for 1.1.1 or 3.3.3. Remember, we are communicating. We are communicating between 1.1.1 and 3.3. But there's no any information. What is the packet format exactly? What is the packet format? So here you have a source public IP 10.1.12.1, destination 10.1.123.2, ESP protocol, ESP, and communication in between. See, traffic is what actual packet is what 1.1.1.1 is trying to communicate with 3.3.3. So what attacker is getting? Attacker is getting only this information. Source public IP, destination public IP, source public IP, destination public IP, ESP protocol, ESP. After ESP, everything is encrypted. Clear now my point? Jagdish, Rohan, Yavar, can you?
Yes.
After ESP, everything is encrypted. So this is a basic lab. Okay, this is a basic lab on site-to-site VPN implementation. Now our focus is on Palo Alto, so we can do a lab, site-to-site VPN lab on Palo Alto, but not today. Tomorrow we can do our lab. Okay, can you, Jagdish, Rohan, Yavar?
Yes, sir. Yes, sir.
Tomorrow we can do our lab. And guys, see, tomorrow, are you guys available on 10:30 a.m. morning? Is it possible, everyone? Only for tomorrow. Rohan, Genu, Jagdish,
मुझे
Yavar.
हाँ सर, मुझे कोई दिक्कत नहीं है सर.
I have no issue, sir.
Okay, Yavar,
So 10 or 10:30? 10:30.
10:30 a.m.
Okay, no issue. I'm available.
Perfect. Genu, tomorrow 10:30 a.m. IST time. Is it possible for you?
Yeah, I can be max. Yeah, I'll be available. That's fine.
Perfect. So everyone, let's do our session tomorrow at 10:30. Okay.
सर
Thank you, sir.
सर मेन मोड और क्विक मोड के लिए आपके पास कुछ डॉक्यूमेंटेशन रहेगा तो
फिर
आप
से बोलिए.
मेन मोड और क्विक मोड जो होता है
हम्म.
जिसमें पैकेट एक्सचेंज होते हैं 6 पैकेट और 3 पैकेट वाला, तो उसका सर कोई डॉक्यूमेंट वगैरह कुछ रहेगा तो आप शेयर कर पाओगे?
हाँ, श्योर. अब आई थिंक आपने शेयर्ड VPN की स्लाइड देखिए, Palo Alto की VPN.